In this video, I am going to discuss matrix and multiplication of matrices. Before defining a matrix, let us consider an example from our daily life. Suppose this is a price chart of some food items in a grocer's shop. Price per kg. Rice is rupees 40 per kg, wheat rupees 35 per kg, sugar rupees 42 per kg, edible oil rupees 85 per kg. Suppose in a family, consumption in kilogram of these food items in the months of January, February and March 2016 be as follows. January, rice 5 kg, wheat 6 kg, sugar 4 kg, edible oil 3 kg. In February, rice 4.8 kg, wheat 5.5 kg and so on. In March, these are the figures. The head of the family wants to make a detailed bookkeeping on the expenditure of these items during these 3 months. He can do it in this way. He has tabulated the prices in this row. Rice 40 rupees per kg. The prices have been taken from this list. Rice, wheat, sugar and oil 40, 35, 42, 85 all in rupees per kg. And here the consumptions have been tabulated. In January, rice 5 kg, wheat 6 kg, sugar 4 kg, oil 3 kg. In February, rice 4.8 kg and so on. Similarly, in March, these are the consumptions in kilogram. Then we can calculate the total expenditure during each of these months in this way. In January, what will be the total expenditure? Rice 40 rupees per kg and it has been consumed 5 kg. So 40 into 5 plus 35 into 6 for wheat plus 42 into 4 for sugar plus 85 into 3 for oil during the month of January. This is the calculation. Similarly, for February we have 40 into 4.8 plus 35 into 5.5 plus 42 into 3.5 plus 85 into 6.5. This will be the total expenditure during the month of February. In March, and the same is the procedure, and this gives the total expenditure in March. Now, after calculation, we will get these 3 numbers. From this, we get 833. From this, February, we get 1084 rupees, and from this, 976.50. Now, if we enclose these figures in a bracket, what we write here is a matrix. This may be called the price matrix. This is the price matrix. We can enclose this in a bracket. The bracket may be a square bracket or a first bracket, whatever you like. This square bracket and the entries within it constitute another matrix. This may be called the consumption matrix. Consumption matrix, price matrix, consumption. And this or this may be called the expenditure matrix. Expenditure matrix. Thus, this tabulation is actually a matrix multiplication, and a matrix is an array of numbers. It may be of one row and a number of columns, or a number of rows and a number of columns. Any array of numbers arranged in the form of a rectangle or a square is called a matrix. And this is the procedure for matrix multiplication. We can explain it further in this way. The same tabulation, the same bookkeeping can be done in an alternative way. Suppose we write the consumption matrix in the left side. This is the consumption matrix. January, February, March, rice, wheat, sugar, edible oil. These are the consumption in kilograms. And this is the price chart written in the form of a column. Rice, wheat, sugar, edible oil. These are prices in rupee per kg. Then what will be the cost matrix or expenditure matrix? This will be in January. For January, we will get this expenditure. 5 into 40 plus 6 into 35 plus 4 into 42, because sugar has been consumed 4 kg and it costs 42 rupees per kg. So 4 into 42 plus 5.5 into 85. In this is the total expenditure in the month of January. Similarly, for February, take this row and this column. You will get the total expenditure in February. This row and this column will give you total expenditure in March. And by calculation, we find the same three numbers arranged in a column. Earlier we got these numbers in a row, and now we are getting it in the form of a column matrix. This is the expenditure matrix in this case. So if we have a matrix of 3 rows and 4 columns in the left and 4 rows and 1 column in the right, then multiplying these two matrices will give you another matrix of 3 rows. This row multiplied by this column will give this element. This row multiplied by this column will give you this element. This row multiplied by this column will give you this element. From this matrix is of size 3 by 4. 3 rows, the first number indicates rows, the second number indicates number of columns. 3 rows and 4 columns. This is a 3 by 4 matrix. And this is a 4 by 1 matrix. 4 rows and 1 column. These two numbers are the same. And on multiplication of these two matrices, we get a matrix of size 3 by 1. 3 by 1 matrix. We can generalize this idea still further. Suppose we now want a bookkeeping for 3 consecutive years, the same bookkeeping for the same 3 months, January, February and March, for 3 consecutive years, 2016, 2017, 2018. The consumption matrix is the same. The family is the same, consumption is also the same. But the prices may fluctuate. In 2016, the prices of the commodities are written in this column during these 3 months, January, February, March, throughout. In 2016, the commodities sell at these prices, 4, 40, 35, 42, 35. In 2017, the prices are a bit higher, 42, 36, and so on. In 2018, the prices of the same commodities are listed here. We can go on in this way. Let us suppose that we want a bookkeeping for these 3 years. Then what will be the expenditure matrix? For 2016, we will have a list of expenditures. For 2017, we will have another. 2018, we will have another list. This is obtained in this way. For January 2016, we have to multiply this row with this column, 2016. For January 2017, we have to multiply this row with the entries in this column, 2017 column. Similarly, this row multiplied by this column will give you the expenditure in 2018 January. Similarly, for February 2016, in February 2016, the expenditure will be this row multiplied by this column. Here I have written it. Similarly, in 2017 February, we will have this row multiplied by this column, and in 2018 this row multiplied by this column. In this way, the total matrix can be calculated. We thus get, we here get a 3 by 3 matrix, a 3 by 3 matrix. We are getting a 3 by 3 matrix in this case from a 3 by 4 matrix. 3 by 4 matrix. This one is a 3 by 4 matrix, and this one is a 4 by 4 matrix. 4 by 4 matrix. This one is a 4 by 3 matrix. 4 by 4 rows and 3 columns. This one has 3 rows, 4 columns, and this one has 4 rows, 3 columns. Upon multiplying these two, we get a 3 by 3 matrix. This. Wipe out these two, you will get a 3 by 3 matrix, like the one presented here. In this way, the general method of multiplication of matrices is depicted here. Suppose this is one matrix, 4 by 3 matrix, and suppose this is a 4 by 4 matrix. What will be the result? This row multiplied by this column will give you the entry here in the first row. Similarly, this row multiplied by the second column will give you the number here. This same row multiplied by the third column will give you the number here. This row multiplied by this column will give you number here. Similarly, second row multiplied by this column will give you the number here. Second row multiplied by the second column will give you number here. Second row, third column will give you number here. This row multiplied by this column will give you number here. Third row, first column will give you number here. This row multiplied by this column will give you number here. This row, in this way. So the general method is take one row, take the columns one by one and write them in the form of a row. First row will give you the first row on the right side. Second row will give you the second row on this side, and so on. This is the general procedure for matrix multiplication. If we have a matrix like this, bold A means matrix A. This is of size m by n. This has m rows and n columns. And suppose bold B is another matrix of size n by p. It has n rows and p columns. Then you can multiply these two matrices and you will get a new matrix C, which will be of m rows and p columns. These two numbers must be equal so that this multiplication is allowed. Number of rows in the left, number of columns in the left matrix and number of rows in the right matrix must be equal. These two must be equal. And the final product matrix will have so many rows and so many columns. If C is the product matrix, the ik element means the element at the ith row and kth column in the matrix C. This will be given by AI1 B1k plus AI2 B2k. B2k means the element in the matrix B at the second row and kth column. In this way, AI1 plus B1k plus AI2 B2k and so on up to AIN BNK. This sum will give you the value of CIK. The sum is written in a compact form in this manner: Aij Bjk, where j is varied from 1 to n. This is the general rule for matrix multiplication. So let us summarize. A matrix is a rectangular or square array of numbers constructed with a definite purpose in view. Two matrices A and B are conformable for the multiplication AB if the number of columns in the left matrix A is equal to the number of rows in the right matrix B. And the third point is this: even if the multiplications AB and BA are both possible, AB is possible, BA is also possible. Even if this is so, the results AB and BA may or may not be the same. We will see this in actual practice. This is a very preliminary discussion about matrices. We have to discuss a bit more on matrices before proceeding to the representation of symmetry operators by matrices. With this, I complete today's video. Thank you all for watching the video. Hey.